Welcome back to the channel. So today we'll be solving question number 4 of chapter 1 sets of CBSE mathematics class 11th. The question is write the following sets in the set builder form. Previously we have discussed representation of a set. And we know that a set can be represented in two ways. Rooster form and set builder form. We have already discussed the rooster form, so today we'll be discussing set builder form, and with that we'll be solving question number 4 after understanding the set builder form. So what is the set builder form? Point number 1, it defines a set by a property or rule that its elements must satisfy. This means that each of the elements in case of set builder form are linked to each other by some common property. This is the first point to be noted and to be kept in mind as well, that each element of a set in case of set builder form is linked to each other by some common property. Point number 2, set builder form can be used whether the given set is finite or infinite. Sets are of two types. A set can be either finite or infinite. Finite meaning it has countable number of elements, and if it has uncountable number of elements, then it's an infinite set. And the set builder form can be used in both the cases. So this is point number 2. Now let us understand this very thing by taking an example. Take for example, we have a set A having elements as 1, 3, 5, 7, 9 and so on. This is an infinite set. So this set in set builder form can be written as the set of all x such that x is, here you can see that these elements are odd numbers. So in set builder form, we'll write it as the set of all x such that x is an odd number. So this very part, the set of all x such that x, means that each of these elements represents some value x, and each x in this case is an odd number. Instead of saying the set of all x such that x, we can only say x such that x, and instead of colons can also use a vertical bar. Keeping this very concept in mind, let us try to solve question number 4. So let us again go through the question. The question is write the following sets in the set builder form. The first part is 3, 6, 9 and 12. Let us name this very set as set A. Now let us first of all observe the property, the common property which links these elements, as we have stated earlier. The elements are 3, 6, 9 and 12. And one can observe that these are the multiples of 3. So the first element is 3 times 1. The second one is 3 times 2. The third one is 3 times 3. And the fourth one is 3 times 4. So let us try to write this very set in the set builder form. So A is equal to the set of all x such that x, or x such that x, is equal to 3n. Here we can see that n is a natural number. It's going from 1 to 4. So it is necessary to mention that n belongs to natural number and n is greater than or equal to 1 but less than or equal to 4. So this is how a set can be represented in a set builder form. Part number 2. The given set is having elements 2, 4, 8, 16 and 32. Let's name this set as set B. So B is equal to. Now let's observe the elements of the set. One can observe that these elements are 2 powered natural number, which means 2 powered 1 is 2, 2 squared is 4, 2 cubed is 8, 2 powered 4 is 16 and 2 powered 5 is 32. So here again we have powers in terms of natural number going from 1 to 5. So the set in set builder form can be represented as x such that x is equal to 2 powered n. Here again n belongs to natural number and n is greater than or equal to 1 but less than or equal to 5. Moving towards third part, the elements of the set are 5, 25, 125 and 625. So let us name this set as set C. So let us observe the elements. So here in this case it is same as that of set B, where we were having the powers of 2. Here in this case we are having powers of 5. 5 powered 1, 5 squared, 5 cubed and 5 powered 4. Therefore this set in set builder form will be represented as x such that x is equal to 5 powered n. Here again n is natural number and you can see that this natural number goes from 1 to 4. So we'll mention it as n is greater than or equal to 1 but less than or equal to 4. Moving towards fourth part. The elements are 2, 4, 6 and so on. So this set is an infinite set. Let us represent this set by D. So set D is equal to. One can observe that it is a set of even number. So we'll simply write that x such that x is an even number. Part number 5th. The elements of this set are 1, 4, 9 up to 100. Now let's name this set as set E. Let's observe the elements. Here one can see that the natural numbers starting from 1 has each a power squared. So 1 is 1 squared, 4 is 2 squared, 9 is 3 squared and 100 is 10 squared. So this set will be represented in the following way. X such that x is equal to n squared and here n goes from 1 to 10. N again belongs to natural numbers. So we'll mention n is greater than or equal to 1 but less than or equal to 10. I hope this makes sense. Do subscribe to the channel for more such content and thanks for watching.